All right, guys. So this is lesson 7.2. Um, first of all, remember that we're skipping number 743, so you don't need to do that one. I could make a video of that one if you want to. I think it's a great problem to know, but we're going to skip it. All right, so we're going to start with 771. Now, what I do realize is that you guys, honestly, I wish we had made this a little bigger because you guys need more room to work out all these steps. And if you watch Mr. Norton's video, there's a lot of steps involved when you're trying to basically write the equation of an exponential function in this form. So that's our form right there that passes through these pair of points. So, and with this given asymptote. So you kind of need a lot of room. So as you're working through these, if you need to do like some of the work on an extra piece of paper, when you submit it, make sure that you put it, or actually you can, you wouldn't do it on an extra piece of paper. Do it in your notebook and label it, okay? And then just submit a picture of this with the rest of your packet. So like you kind of have some of the steps on here and then the rest of the steps here. Have it all together, just like take pictures of it, each of it, and submit it all together. I'll be able to sort it out, okay? All right, so starting with this first one, we're given 2 points. Okay, so what we're going to do is we're going to set up the equation using this form and these 2 points. Remember, this is from the 7-2 Ed Puzzle notes that Miss Menard did. Okay, so first steps we're going to do is we're going to take this point and we're going to plug it into this formula. Okay, so remember, this is an x value, this is a y value. I'm going to plug it here to x, here to y, and I'm going to plug in this asymptote into the k value. Okay, because the asymptote is basically what is defined from this k value. Okay, so first we're going to plug in the y, which is 6, equal to a. So remember, we're basically what we're trying to do, guys, is we're trying to figure out what a and b is by creating these equations. So we don't know a and b. All right, raised to the power of x, which is the 0.5. So 0.5, and then plus our k, which is 2. All right, so what we want to do first is we're going to solve for a. So in order to solve for a, we need to isolate the b, okay? I'm sorry, not isolate the b, isolate the a, okay? So first we're going to subtract 2 from both sides, so we get 4 here. So a times b to the 0.5. Okay, then we want to isolate a, so we're going to divide, okay, this b, point b to the 0.5. We're going to divide it on both sides. B to the 0.5, okay? And now we get 4 over b to the 0.5 equals a, okay? Now we're going to do the same thing again with the other point. So now 488 equals a times b to the 5th power plus 2. Subtract 2 from both sides. It's 486 equals a times b to the 5th power now, and we'll do the same thing. Divide by the b term, and then a will be equal to 486 over b to the 5th, okay? Now, since we have both of our equations equal to a, we can use the rule of substitution. So this is where my other piece of paper is going to become useful because I need more room. All right, so both of these are now equal to a. I'm not going to write, well, okay, I'll write it again. One more time, just for you guys. Okay, so now it's equal to a. So if these are both equal to a, I'm going to make them equal to each other. All right, so let's do that over here. So 4 over b to the 5th equals the 486 over b to the 5th. Oh, I'm sorry, that's actually 0.5. Careful, that's a 0.5 right there. It's a decimal over b to the 5th. So here's the deal with this one, though. Notice how we have b by itself, right? So that means we're solving for b first, okay? So first thing we're going to do is cross multiply. If you watch my other video, there is a trick, but I'm not going to do that here, just so I don't want people getting confused. And then equals 486 times b to the 0.5. Remember, that's a decimal. All right. Now, again, we want to get b by itself. So the first thing I'm going to do is I'm going to divide the 4 on both sides because I'm going to want b on my left. So now I have b to the 5th equals let's divide that. So 486 divided by 4 is 121.5. It didn't come out as clean as I thought it would. Okay, so 121.5. And you just got to make sure you're keeping track of your decimals here. Okay, times, remember, b to the 0.5. All right, so keep track of your decimals if you have any. All right, like up here, you guys might have to, looks like, well, at least for you guys, you don't have to deal with that in the x value. I do. All right, so it'll be a little easier for you guys. So now I'm going to divide that on both sides so I can get b by itself. All right, so now this will be equal to 121.5 over here, and just because that'll cancel. So now I want to use my exponent rules, and if I divide, that means I subtract. So 5 minus 0.5 is 4.5. Okay? Now, when you have a variable raised to a power and a number on the other side, we take a root of both sides. Okay, and it's not a square root because we want to raise it, we want it to be the same power as this 4.5. So whatever that is for you guys, it won't be a decimal, by the way, in your problem, because you're basically going to be using that number there. These two numbers there, those are whole numbers, so you shouldn't end up with a decimal. So I'm going to take the 4.5 root of both sides, okay, and that will be my b value. So let's do that here. So I need this function right here, and my index will be 4.5, and then the inside I got 121.5, and I get 2. Let's round to the nearest thousandth, okay? So 2.905. Actually, no, this is just a b value. We'll go to the nearest tenth. So 2.9. All right. So b equals 2.9. Okay. There we go. So there's b. Now we got to find a. All right. So now to find a, basically what we'll do is we'll plug the b back into the equation. So I'm going to plug in b here. I haven't plugged in, actually, yeah, let's go ahead and plug in a y. And then we have b, which is 2.9 to the x, plus k, we already know k, remember that was the asymptote, that was this value here, so plus 2. So now, to solve for a, all we need to do is plug in one of these points, and it doesn't matter which one you plug in. Okay, I'm going to plug in that one because it doesn't have any decimals. I don't want to have to deal with decimals in this problem. So y goes there, just like before. And then the x goes up here, the 5 plus 2. All right, so first thing I'm going to do is subtract the 2, equals 486. And then I have a times 2.9 to the 5th. So let's go ahead and raise that to the power of 5. 2.9 raised to the power of 5 is 205.11. We'll go 2 decimal places there. So 205.11 times a. And then the last step to isolate here is to divide both sides by this 205. Now mine is going to end up with decimals, okay? Your problem will not end up with decimals for your a and b values. So I kind of had to make this problem up, and it's hard to make problems up like this without spending a ton of time coming up with one. Okay, so we'll round that to the nearest tenth, so 2.4. Actually, that was 2.3, huh? Oh no, it was 2.4. All right, so now my final equation here is going to be y equals the a, 2.4, times 2.9 raised to the x, and then plus that 2. And I could round that to 3 if I wanted to. So again, your guys' problem, remember, will not end up with decimals. You guys should end up with whole numbers in your problem for your a and b value. Okay? All right. Okay, so again, this is pretty much the same problem as this one. So I'm not going to go through this one for the sake of time in the video, but it's pretty much the same steps. Okay, it is the same steps as the problem before. Okay, just be careful, mindful of your decimals and of your negatives. Okay, as you guys work through that problem. Okay, now, Barnaby's grandfather, remember again, I'm changing all the numbers, so use your numbers when you solve this. Barnaby's grandfather is always complaining that 40 years ago, he could buy his girlfriend dinner for $2, and now the same dinner costs $23.10. So obviously it's increased in price. Assuming the prices increase exponentially, and that the same dinner never costs less than 10 cents, write the equation of a function that models this relationship in a number of years. Okay, so first of all, this, because it will never go below 10 cents, it will never be below, that's an asymptote. It's like a limit, right? So our limit here, asymptote, is going to be 0.10. Okay, so just remember that's like the k value basically. All right, so now just like these two problems, we need 2 points to figure out the equation. Our first point, let's think about like right now in time is today, right? 40 years ago is like going back in time. So that means that my x value is going to be negative 40. And Miss Menard, if you guys watch the end of the ed puzzle, already gave you guys these values, okay? So negative 40, and then my y value for that time and place 40 years ago is $2, okay? My second equation, which is today, and remember today is like our starting point, and then we're working backwards. Today is 0, okay? So we're considering today is our 0 day, okay? And then the y value, which is the cost, is 23.1. So I'm just kind of dropping those zeros off because I don't need them right now. All right, so now I'm basically solving it the same way like we did before. Okay, I should have enough room to be able to solve this out. Okay, so the first thing we're going to do is let's set up what we know. We know y equals a times b to the x plus 0.1 or 0.1. That's the y value there. I just took off the last 0. All right, so basically, again, we have to solve for the a and for the b. All right, so what I'm going to do is I'm going to plug in this point here. And the reason I'm going to plug in that point, because there's a 0. And zeros usually mean things cancel out and make things easier to solve, okay? So that means the y is 23.1. The a is a, which we're looking for. And then the x, the 0 goes. Now, if you remember, anything raised to the power of 0 is equal to 1. So if it's equal to 1, it basically goes away. Or it's a times 1 now, which is just a. That makes things easy, right? So now I have 23.1 equals a plus 0.1. So now I just basically subtract the 0.1 from both sides, and 23.1 minus 0.1 is 23. So area value is equal to 23. Okay, so we got a. So now we just need to find b. So to find b, we'll just plug that into the equation. We'll plug in the a now. So what I'm going to do is, since I already used this point, I got to use the other point to solve for the b value. Okay, so now I'm going to plug in the 2 for the y. We already know the a, so that goes first. And then it's the b raised to the x power, which is, in this case, negative 40. Yes, it's going to be a huge exponent. And then plus our k value, all right, which is 0.1. All right, so now first thing we want to do is subtract the 0.1 from both sides. We're basically working ourselves around to get that b by itself. So now we have 23 times b to the negative 40. And then we're going to divide by 23 on both sides here. So that cancels there. And we get 1.9 divided by 23 equals b to the negative 40. Now, you guys remember in the past when we had a number, something like, let's just say, any variable raised to an exponent, and you have something on the other side, I would root both sides, right? And the root depends on your exponent. Okay, so if my exponent is 3, I would do the cube root. If this was a negative 3, I would do a negative cube root. Okay, so it doesn't matter whether it's positive or negative, you just do the same sign. So here, basically, I'm going to do the negative 40th root, negative 40th root. There is such a thing, and of both sides. So that cancels this out, and it will just be here. So let's do that with a calculator. But there's no way I'm doing that in my head. I honestly don't even know how to do that. I wonder if there is a way to do that by hand. I don't know if I really want to go there, so I'm not going to. All right. There's some things that just aren't supposed to be done if you don't really need to be done. Okay, so we'll round to the nearest, let's go 10th. So 1 point, actually we'll go to the nearest like 1,000. So 1.064. That's our V value. So 1.064. And the reason I want to keep that pretty accurate and go to the thousandths is because the next step we're going to need that value. We're actually going to calculate something. Okay, so now the A value is 23. The B value we'll put in parentheses. Raised to the x power plus the 0.1. Okay, there is our equation for the first step. All right, so that was the model right equation that models this situation. So now, how much would you expect the same dinner to cost now 30 years into the future? So first we had a value that was 40 years behind. Then we had the value of what it is right now. Now they want to know what's the value, predicted value 30 years in the future. Okay, so basically all we're going to do is plug in our 30. And our 30 is the x, is that input. And remember, inputs are also x, so that basically means we're going to plug it into x. So basically we're going to set this up as 23 times 1.064 raised to the 30th power, because that's our input, plus 0.1. All right, so guess what? Calculator time. So this one's not too bad because we're just basically using the equation to plug it in. That's the point of making an equation, is to be able to just plug in a value and make a prediction without having to work through a bunch of steps. And don't forget, you got to add that little 0.1 at the end. And there it is, 148 bucks. That's a lot. And remember, this is money, right? So we want to round that to the nearest cent. That 2 is not going to change things, so it's $148 even. $148.00. Okay. All right, that's an expensive meal. I don't know if I'm going to be going to McDonald's, and I'd still be like $50, right, for just a Happy Meal. Okay. Anyways, next one. All right. So now, oops. Hold on, let's drop that paper. Okay. So now in this one, we're still going to be using the same equation. Okay. So remember that, we've got there y equals a times b to the x plus k. All right. So now again, I'm changing all the values again. So a 2-bedroom house. So this is definitely a more relevant problem because this stuff is kind of true. But the market does kind of go up and down with house values. So it doesn't always just go up. But over like long periods of time, it does go up, by the way. All right. So 2-bedroom house in Seattle was worth $350,000 in 2001. Okay. Its appreciation rate is 2.8% every year. Okay. So here's the important thing about working with rates, whether it's money or whether it's house values or car values or anything values, right? You need to convert your percent before you use it. So my rate, just 2.8, I'm going to convert that into a decimal. And I do that by moving this 2 spots, the decimal 2 spots. So that means this is going to be 0.028. Okay, so make sure you move your decimals before you use it. Now, if you guys remember multipliers, you guys remember working with multipliers, I don't just use this as my b value. What I'm going to need to do is add 1 to that. So I'm going to add 1, and that will be equal to my b value. Okay, so you always add 1. So basically what you're doing is you're adding 100%. 100% plus 2.8%, because you're basically increasing the value, you're multiplying the value by 102.8%. So this now becomes 1.028. Okay, so if you are adding, if you're increasing, which that's what appreciation means, then you're going to add this to 100%. If you were depreciating, you were going down, which is like the problem that we skipped on the front, then you would actually subtract that number. You would subtract from 100%. So keep that in mind. All right, so anyways, how much is the house worth in 2013? Well, first let's set up our equation. Okay, so we know that our equation is our A is going to be whatever we started with, like the principal amount. Principal means like what you started with, which is 350,000. And then the B is going to be your rate, which is the 1.2028, or the rate plus 100% in this case. And then raised to the amount of time. Now remember, in 2001, this was the value, and we want to know what it was in 2013. So that would be how much later? 12 years. So that's my value I put up there. Now in this case, there is no like minimum value that they are stating. So we don't have a K value. So the K value in this case is equal to 0. Okay, so unless like they state like some value where it's only going to never go below here or never go above, then you would go ahead and just make your K 0. Okay, so then I just go ahead and calculate that now. 3, make sure you put the right amount of zeros. 1.028 raised to the 12th power. And we're going to round this to the nearest cent. So $487,000, $487,512.12. So $487,512 and was that 12 cents? 12 cents. Okay. Now, when will it be worth $700,000? So when will this, so in other words, if you want a way to think about this is, when will this equation give us $700,000? When will it be equal to? So now we're not solving for y, we're solving for the when, which is the x part of the equation. So we got to solve for x in this case. All right, so the way we set that up is I'm going to make the equation equal to 700,000. So 700,000 equal to the 350,000. Remember, yours is 400 times our multiplier. So again, this is not really a rate. This is a multiplier because the rate is actually the 2.8, right? So this is called our multiplier. Let's write that in here. Multiplier. Okay. So now what we're looking for x, right? So it's raised to the power of x. So now what we want to do is just like we did in the, if you guys remember with log in 7.1, we're going to get that x by itself first by dividing this number in the front. So now we're applying that log, those log skills that you guys learned before to be able to solve these types of problems. So now we divide this. Now, my trick here is that when I have a bunch of zeros, I cover up the same amount of zeros to the right. So I have 1, 2, 3, 4 zeros. So I'll cover up that many. And especially just 70 divided by 35, which is 2. So 2 equals 1.028 raised to the x power. And now if we recognize this type of problem, this is where we put into log form. And our base is that 1.028. Our a value is the 2. And basically that will give us our x value. Okay, so let's, now remember, if you remember when the base is not 10, you got to use the graphing calculator version. All right, if you're using Desmos. Okay, so 1.028. Okay, and our a value was 2. So 25.1. So about 25. Remember, this is all about when will it be worth this much money. So in 25 years. Now, what if it's saying when, right? It's not saying how long, it's saying when. So it's asking what year. Well, if we're starting in 2001 and it's 25 years later, that means that we're actually going to be, it'll be this value in 2026. So that's really what the question's asking for, okay? Not how long, but when. Okay, so what year specifically? That's how you kind of set that up. Okay, so now in Jacksonville, houses are depreciating. So now they're going down, like I was saying before, they're going down this time by 2.5, yours is 2, per year. Okay, so here's the initial value of the house. How much will the house have lost? How much value will it have lost in 15 years? Okay, so here's the deal. we need to figure out what is the new value in 15 years, and then figure out the difference between the first value and the new value, because that's what it wants to know. How much has it gone down? Not how much is it, but how much has it gone down, okay? So let's first set up our equation to figure that out. So first we're figuring out what's the value in 15 years. Now, the key part is your multiplier. Now, remember, if it's depreciating means I'm going down in value. So that means I need to take away. So when I create my B value now, guys, I don't do 1 plus the rate. I do 1 minus the rate. And remember, first change this into decimal. So this will be 0.025. So now 1 minus, take the calculator out. No shame in the calculator. Okay, so 1 minus 0.025, 0.975. Okay, so that is our B value. That is very important. And it makes sense, because if you multiply times a number that's bigger than 1, the number is going to increase, right? If you multiply times a number that's less than 1, they're going to decrease. All right, so now we got to raise it to our x value, which is, in this case, 15. All right, so let's go ahead and plug that in. So 250,000. Yep. Okay, times 0.975, and then we're going to raise that to 15, and we get, so that's our new value, $171,005.17. Now, like I told you before, remember it's asking how much has it gone down, right? So it started at 250, and now it's down to 170. That's a little high. That's a huge drop. How much did it lose? All right, so now we're just basically going to subtract. So we're going to go to the next line. I'm going to do 250. I'm going to basically subtract the two numbers. The nice thing is, so the nice thing about this is that I can do minus, not there, after the problem there, minus, if I push answer, it basically subtracts what I got from before. So here is, something's off. Oh, sorry, I made that 2 million. Or 2.5 million. Too many zeros. Okay, so yeah, check your answers if you're like, it seems something seems off. Okay, so $78,994.83. We got to round that up. So that's the reduction in value. That's how much it went down. Okay, let me write that down. So $78,994.83. Okay. Oh yeah, it's not X, I'm sorry. It's not even Y, because that's actually Y. So this is how much it went down. Okay. So now if you guys remember this problem, this is more practice on this problem. Okay. So you guys are going to set that up the same way. Okay. I will go ahead and help you guys out with this one. All right. So remember, again, if you guys need to do this one on a separate piece of paper, totally get it. That's totally fine. Just make sure you label it. Okay, so as you're going through it, you want to make sure you label this 718 on that piece of paper and take a picture of it as you work through it. Okay, so let's go ahead and kind of fly through this. All right, so remember, we got to use this equation, right? So we're going to go ahead and plug in these values. First, set up our equations, and then we'll use this paper for the rest. All right, so we got, remember, we don't have A and B. So this is raised to the 1 power. And then we got to put our asymptote, which is our K value at the end. All right. And then we'll do the same thing for this equation. Let's kind of simplify this one first. This one's actually an easy one here. At least for mine it is. You guys have a 1 as well, so that'll be easy for you guys. So now it's equal to A times B. And B to the 1, I don't have to keep the exponent anymore. So then I just divide both sides by B. And 9 divided by B is equal to A. So that's a pretty simple one. All right, so now this one, I got 2,046 equal to A times B to the 5th power minus, oh, I am sorry. I totally put a 3 there because I saw 3 up there. So that's minus 2. So I got to change this, and that's 8, and that's 8. Okay. Again, so that means I should be adding 2. All right, so now here, again, same thing. Add 2 first. And so that's 2,048. And basically, I'm going to end up dividing by that b to the 5th. So I'm going to go ahead and just write that in there, just to save ourselves a step. Okay, no, I didn't. I lied. All right, so then again, you divide both sides by b to the 5th here, and then that's my new equation. I forget I've got plenty of room because I'm going to be using this other piece of paper. So there's my equation set equal to a. So now I've got the 2 equations set equal to a. So now let's make them equal to each other. So now 8 divided by b is equal to 2,048. And I'm going to show you a trick here. I showed you guys this in the last homework help video for last week in 7-1. But with the nice thing about cross multiplying is that I can just switch numbers as long as they are diagonal from each other. So what I'm going to do is I'm going to switch this 8 to here and this b to the 5th up here. And I want to make sure that I put the bigger value on top. Okay, so that I end up with positive exponents. So in other words, if I had the bigger b value over here, I would switch this one up to here. All right, so then this becomes b to the 5th over b. And you can just do traditional like cross multiplying like I did in the last problem. Go look at the last one if you want to see how I did that. But this is the shortcut. And so basically now the 8 comes down here. So I have 2,048 over 8. All right, so now I can simplify this part. And remember, this is just 1. So basically, when I divide, I subtract. So 5 minus 1, so b to the 4th. And then I would divide this into each other. So 2,048 divided by 8. Oops, where did my calculator go? All right, so 2,048 divided by 8 is 256. And now we're going to take the 4th root of both sides to find our b. And basically what I'm going to do on the next line is do 4th root of a. Oops, wrong spot. I got to put the a in the answer in there, so it equals 4. So b equals 4. All right. So now I got to find the a. So to find the a, I'm basically going to take the b and plug it into the equation. And I'm going to take one of these points. I'll take obviously the smaller numbers and plug those also in. So now 6 equals the a times our b raised to the x value, which in this case is 1. And then I got to put the asymptote minus 2 at the end. Okay, so let's simplify. So 4 to the 1 is just 4. So it's 4 times a, and then minus 2 here. So plus 2 equals 8. And then divide by 4, a equals 2. Okay, so now our final equation is y equals 2 times 4 raised to the x power, and then I got to put the asymptote, which is minus 2. Okay, so there's our equation. So again, this one is going to be the same setup. So you set this one up the same. Just be careful with your negatives. Make sure if you're dividing like a positive by a negative, it's still negative. If you divide a negative by a negative, it's positive. So pay attention as you guys work through that. So again, you're doing this the same way. Okay, so this is the same. All right, so now in the next one, okay, got another problem dealing with kind of a situation that has to do with population. So again, remember I changed out all the numbers. So here in 1994, Terre Haute, Indiana, that's the name of the city, had a population of, in this case, we're going to do 62,000. And in 1998, the population dropped to 60,142. City officials expect the population to eventually level off at 45,000. All right. So first of all, the question is, what kind of function would best model the population over time? Well, if something is going to level off, it's not going to like just continue to decrease like kind of linearly. It's going to kind of level off. Anytime you hear that kind of wording, you know this is an exponential situation. I mean, all these problems we're doing are exponential anyways. Okay, so we know that, which means we're going to be using this equation. A times b to the x plus k. Okay, so with that, let's plug in our values. So the one thing that we know is that because it's leveling off at 45,000, that is a k value. But we don't know the b value, we don't know the a, so that's what we got to look for. All right, so now here's the deal. We're starting with 62,000, and we know that it's going to level off at 45,000. So we already know the total amount of population we're looking at, the total change. So we know that the total change from 62 to 45, let me write that here, the total change is 17,000. So we know that there's going to be like this reduction of 17,000 people. So that's really all we're going to focus on in the equation, because we're not looking at a whole 62,000. Since it's stopping at 45,000, we're only focusing on that part that is changing. You need to take your temperature every day. Sorry about that, guys. I had to kind of pause it because of the announcements. Okay, so that is our A value. That's what we're starting with, because we're starting with 17,000 and we're trying to see how will that decrease over time. So that is A. So really, what we're looking for is we're coming up in the equation by looking for B. Okay, so now here we're going to plug in the A value, which is 17,000. So you got to look at, okay, you started with 72,000 and leveled out at 60. What's the difference there? And that's going to be your A value. Okay, so now times B to the x, and then plus 45,000. Okay, and your K value is 60,000. Okay, so now what I want to do is let's go ahead and plug in this value of 60,000 to the y. Okay, and we know that it's going to be 60,000 from basically going from 1994 to 1998, which is 4 years, a 4-year change. And notice yours is going from 98 to 2000, so you only have 2 years. So that'll be your x value. Okay, so my x value is 4 because we're looking at the change over 4 years. All right, so now we're going to basically isolate b. So let's subtract the 45,000 here on both sides first. Okay, so 60,000, 142 minus 45,000, 15,142. Times b squared, or sorry, b to the fourth. Okay, now what I want to do is divide here. Divide by the 17,000. Okay, let's do 17. Oops, sorry. So let's do 15 for 2 divided by 17,000. I'm going to round this to the nearest thousand. So 0.891. Actually, let's do the nearest 10,000. So 8907. So it's basically b to the fourth equals 0.8907. Okay, so now to the fourth, so we take the fourth root to find our b. So I'll pull up the new line, fourth root, and I'm just going to go ahead and go here and press answer. So I can get the most accurate answer here. So that means my b is equal to 0.97. We'll go to the nearest thousandth, so 0.971. So b is equal to 0.971. So that means our equation is what we're trying to look for is 17,000 times our b value, which is 0.971 raised to the x, plus 45,000. Okay. All right, these last ones here, log. Okay, so now this last few problems are all log review. So if you go back to 7-1, I go through problems just like this. So remember when you're starting with a log and we want to evaluate it, we're trying to figure out what it's equal to. So I like to just set these all equal to x. Just it kind of gives me like a reference, so I kind of know what I'm solving for, even though you don't really have to put that in there, but it is helpful. All right, so now again, I want to put these back into exponential form. I want to use that the ability to go back from log to exponential. So remember that log base b is equal to the base raised to the exponent equal to a. So my base, remember if there's nothing written, is automatically 10. So I'll write 10 raised to the e. Remember your e is this value over here, so 10 to the x equals the a. So in other words, what number raised to the, what do I raise 10 to what power equals 100? Well, that's 10 squared. So what I can do is change the base or make a common base over here on the right and change that to 10 squared so I know that x equals 2. Okay, same thing here, except inside the parentheses here, this is a third root of 10. Okay, so again, I'm going to do the same thing. So 10 to the x, because that's the base there, equals the third root of 10. Now I'm going to use the rational exponents method to change this back into exponential as well. So remember that the exponent here on the 10 is a 1. And I'm going to raise this to a rational exponent, in other words, a fraction exponent. So the 1 goes on top, the 3 goes on the bottom. Okay, and now that they're the same base, they're both a common base, that means that x equals 1/3. Okay, so now here, again, let's go to exponential form. So 6 to the x equals 0. There's a problem there. There's no number that I can raise 6 to get it to equal 0. And let me show you what I mean. If I like type in log base 6, so let me get the log here. Log base 6 of 0, look what happens. It's undefined. There is no value where I can plug in a 0. And if you guys remember the graph of log, there's an asymptote at x equals 0. So you can't plug in 0 to a log. So that means it's undefined. So there's no value here. Okay, so anytime you see log or 0 plugged into a log, it doesn't work. It's not a part of the domain. So that would say, it would call it undefined, okay? Or or you could say no solution, but really we're not solving for x, so undefined would work. Okay, so then again here, now we're in exponential form. So we're actually gonna go back the other way and go back into log form. Okay, so remember this is my b, so log base 10 there, of your a, which is x. So that means that this is all gonna go on the other side. So 3/4 times log of 16. Now, you guys remember a problem like this last week, when there's a number in front of the log, I can use the power rule to switch it back from the front back into the exponent here. So what I'm going to do is move this to the exponent of the 16. And I'm probably going to end up using another piece of paper here. Okay, so now I've moved that to the top there. So I've got 3/4 up there. So kind of just like this problem where we had rational exponents, I'm actually going to go back into the radical form now. But before I do that, just a reminder that now I have a log on both sides, or one log equal to another log. I can actually cancel these logs. Okay, so I'm going to use another piece of paper because I'm running out of room. So make sure that you label this. Again, if you decide to do this. And I got problem D here. So I'm going to continue on. Oops, sorry, I don't need to write the log because I already canceled them out. So it's x equals 16 to the 3/4. So now let's go back into radical form now. Okay, so x equals remember that this number becomes the root, and the 16 goes here. And what I'm going to do is you can put the exponent inside, or you can put it outside with parentheses. So either is still equivalent. It still works, okay? So now what I'm going to do to simplify this is I'm going to do the fourth root of 16. Well, in other words, what number do I multiply 4 times to get 16? So you can use the calculator. You can use a scientific calculator, or if you already know the answer, that's fine too. But basically, I'm doing the fourth root of 16, and that would be 2. It's 2 times 2 times 2 times 2 is 16. So that means inside here, I'll have a 2, and I'm still raising that to the third power. So I'm multiplying 2 3 times, so 2 times 2 times 2 is 8. So x equals 8. Okay? So again, make sure that if you do another piece of paper, you take a picture of that. Okay, so now what we're going to do is we're just rewriting this into a one log. Okay, so we're not solving for x or solving for y. We're just going to rewrite this into one log using our log rules. So first, before I can combine these two logs together, I want to get this 5 and use the power rule to move this 5. So I'm going to move that there, just like we did in the last problems. So now it's x raised to the 5th plus log base 4 of 3y. And actually, matter of fact, let's put that inside the parentheses. I don't need to put that outside. Okay, so now I can combine these. And remember, if you're adding 2 logs, that you multiply these 2 numbers inside. So x to the 5th times 3y. So I'll put the 3 first, and I'll put the x and the y. So 3 times x to the 5th times y. Okay, and then that's it. Now it's condensed into one log. Okay, so now this one, kind of the same approach. First, use the power rule to move that there, the exponent. Okay, now you got 2 logs that are being subtracted from one another. So now this is the quotient rule. That was the product rule, right? So product, first I use the power, okay, on both first steps here. But now it's going to be the quotient rule, which is basically division, the division rule. Okay, and when you combine them now, again, log base of 5, and now I divide. So remember, the first one goes on top, the second one goes on the bottom. So it's x to the 4th divided by 2y. Okay.